Good morning, Year 8. Today we are looking at introducing rates and solving some rate problems. First thing we're going to do is learn how to simplify rates. Now, when we learnt about ratios, we learnt that we made the units the same if there was any units involved, and then we simplified down and there were no units in our answer. However, rates are different to that in that we're going to be comparing two different types of quantities and that we need to have units in our answer. So to do this, we start by writing our quantities as a fraction. If we do 240 kilometers in 5 hours, so I've written it as a fraction, you want to divide the numbers, so you're 240, you can use the fraction or the divide button, over 5, and that makes 48. To do the units, whatever was on the top of the fraction goes first, and on the bottom of the fraction goes second. So it will be kilometers, and then we do a slash, which means per hour. So this relates to 48 kilometers per hour. Part B, let's do it again. This time we have $84 on the top, and this is done in 6 hours, H for hours. So to simplify that, we're going to divide the numbers. 84 over 6 gives us 14. And $14, so dollars is the only thing that we put in front of the number. All our other units go after the number. And so it's dollars per hour. Part C, we have 68 runs that are done in 8 overs. Okay, so dividing our numbers, we go 68 over 8. So fraction probably doesn't make much sense. Let's press the SD button, turn it into a decimal, and that's 8.5 runs are on top per over. Part D, we have 36 apples for $5.40, and it says in brackets that we want this as cents per apple. That means that we want to have the money in cents on top and the apples on the bottom, even though they're written in the opposite order here. So we have dollars here. To change that into cents, we're going to times it by 100, which makes 540 cents. Okay, so then we want 540 cents per 36 apples, and then we can divide them. So 540 over 36 is 15 cents per apple. Question 2. Convert the following rates into the units given in the brackets. So we have $18 per hour, and we want to know what this is in cents per minute. So we're going to use our fraction to help us. If we have $18 in 1 hour, so per hour means 1 hour. So I've split it to the two unit components so that I can convert each of them separately. I'm going to convert the dollars into cents. To do that, you times it by 100. And I'm going to convert the hours into minutes. There are 60 minutes in an hour, so I have to times that by 60. So 18 times 100 is 1800 cents now. And on the bottom, 1 times 60 is 60, and that will be now in minutes. So I've changed the units into the ones that I want. Now I divide the numbers. 1800 over 60 is 30 cents per minute. Question B. Same kind of question. We have 600 grams per day means over 1 day. And I need to change it to be kilograms on the top and weeks on the bottom. Now, kilograms are a bigger unit than grams, so you need to divide by 1,000 to turn that into kilograms. And days, there are 7 days in a week. So you're going to have to divide that by 7 to turn that into weeks. So in our calculator, or we don't need a calculator for the top one, 600 divided by 1,000 is 0.6 kilograms. The 1 day is a little bit trickier because if you go 1 divided by 7 or over 7, you either get a fraction or a pretty nasty decimal. So it's probably better to leave it as the fraction. And so we have 1/7 of a week on the bottom of the fraction there. Okay, it's all right to have a fraction in a fraction. Our calculator can handle that. So let's type this in. We have a fraction with 0.6 on the top, and on the bottom we have a fraction 1/7, and there it is. It's equal to 4.2, and that will be kilograms per week. Okay, question 3. Tom was 120 centimeters tall when he turned 10 years old, and he was 185 centimeters tall when he was 20 years old. Find Tom's average growth rate between 10 and 20 years of age. So we don't normally have 4 numbers working in our rate here, but we need to do some subtracting. So first of all, we want to know how much Tom has grown. Okay, so he started off at 120 centimeters tall and he grew to 185 centimeters. So if I take his 185 and take off the 120, that means that he has grown 65 centimeters. Also, I want to know how many years this has happened in. So he started off at 10 years old and then this finished when he turned 20. So that's a difference of 10 minus 20. That's 10 years that this measuring was taking place. So if I use these measurements, they're the ones I want to use to do the rate. Tom has grown 65 centimeters in 10 years. And then if you divide that, 65 divided by 10 is 6.5 centimeters per year. Question 4. Martine grew at an average rate of 6 centimeters every year for the first 18 years of her life. If Martine was 50 centimeters long when she was born, how tall was Martine when she turned 18? So let's work out how much what her growth was in the first 18 years of her life. So it says in the first part of the question that she grew at 8 centimeters per year for 18 years of her life. Okay, so 6 centimeters per year means in 1 year she grows 6, in 2 years she'd go 2 lots of 6, but in 18 years, if I times that by 18, that means that she has grown 108 centimeters in those 18 years. The second part of the question is, what is her total height now? Because she didn't start at 0 centimeters, she started at 50 centimeters when she was born. So she started at 50, she grew 108, so if I add those together, she will be 158 centimeters tall. Question 5. A casual teacher earns $334 per day and works for 7.5 hours. Calculate their hourly rate. So that is how many dollars they earn per hour. Well, they earn $334 in 7.5 hours. If we divide those, 334 over 7.5, well, we're going to have to round this because we're talking about money here. We'll do 2 decimal places. So 44.53, 44.53, and that would be dollars, which go out the front, per hour. Part B, how much is this teacher going to earn weekly when they work for 5 days? Well, they're getting $334 for 1 day. So if we want 5 days, we would times it this time by 5. So we go 334 times 5, they are getting $1,670 for the week. Question 6. Luke drives 120 kilometers in 3 hours. How far will he travel in X hours? So remember when we did ratios, I said that setting these things up as fractions will be helpful. So we're going to use that same strategy now, setting this up as a fraction. So the first part of the question says that Luke drives 120 kilometers in 3 hours. And then this needs to be equal to, because it says how far will he travel? So that will be the kilometers part that I'm trying to find. Because I'm trying to find it, I'm going to call it X. That's my bit I'm trying to work out. And he will do whatever that distance is in 5 hours. So the important thing in setting this up, the reason I've written units on my fractions, is that I have kilometers over hours, and then my distance here would be kilometers over hours as well. So they need to be in the same order when you set the fractions up. But once it's set up, you don't need the units in your working out here. But to find out what X is, we cross multiply the numbers. So we go 3 times X is 3X equals 120 times 5 is 600. Then to solve the equation, we divide by 3 and we get X is equal to 200. And remember that X is representing how far he traveled. So that's going to be in kilometers. So he could do 120 kilometers in 3 hours, or he can do 200 kilometers in 5 hours is what we've worked out. Next page for a few more like that. Question 7. Lexi types 480 words in 10 minutes. So again, we set this up as a fraction. 480 words in 10 minutes. How long will it take her? So the how long part, that's going to be the X, and that's a time. So the time needs to be on the bottom. We're working out X on the bottom here. How long will it take her to type 864 words? So that 864 goes on the top. This is why the fractions are so helpful, because sometimes the X is on the top and sometimes it's on the bottom. And doing it in other ways, that can be a little bit confusing as to when to times and when to divide. Okay, so with our solving, we're going to cross multiply, starting with the X. I'm going to do X times 480, so that's 480X. Then I'm going to do 10 times 864, which is 8640. I don't need the units anymore. Now to solve the equation, I'm going to divide by 480. Okay, to get rid of that from the front. Okay, dividing those numbers, we get 8640 divided by 480, which is 18. And remember, this is the X was representing how long it will take, and our time unit was in minutes. So it's going to take her 18 minutes to type the 864 words. Question 9. Willow is a chef that can prepare 45 meals in 3 hours. So that's 45 meals in 3 hours. If she needs to prepare 75 meals, so the 75 meals will go on the top. How long will this take? That will be the time, which is going to be X, that I put on the bottom of that fraction. Okay, now to solve, starting with the X, timesing diagonally. X times 45 is 45X equals 3 times 75 is 225. Then to solve it, we're going to divide the 45 to get rid of that. X is by itself, and we get 225 divided by 45, which is 5. 5 what? Remember, X is on the same level as the hours, so this is 5 hours. It will take her 5 hours to prepare 75 meals. Question 8. A car travels at 70 kilometers per hour. How far can it go in 2 hours? If it goes 70 kilometers in 1 hour, To find out how far it goes in 2 hours, you just need to go 70 times 2, which is 140 kilometres. In part C, it says 45 minutes. The thing you need to be careful of is if my speed here was in kilometres per hour, I can't be using minutes as something that I put in my calculation. It needs to be in hours as well. So to change 45 minutes into hours, there are 60 minutes in an hour. So you divide the 45 by 60, and that will now be in hours. You could simplify the fraction down, but I wouldn't worry about that. Your calculator will do that when we do our calculation in just a minute. So, like I did for part A, if they are going 70 kilometres per hour, I times it by the 45 over 60, which is the time in hours, and that will tell me how far they've gone. So 70 times 45 over 60 is, got a funny fraction there, so press the SD button, 52.5 kilometres. Okay, so that's it for our theory section. Time for you to do some practice in your workbook on page 11 through to 13.